It's very interesting. You know, the curious mind is lovely. Okay, so let's say when we have a situation like this, and this. The thing is this, if you don't worry about anything, we can go into this and look at what we can say it's a first order analysis. Wow, first order analysis. Of course, everybody knows that this better be equal. Let's say I'm not gonna make life difficult. So let's place this at the middle. So you know it's a half of the reaction. So there's no reason for this not to be equal. So if you look at the first order, meaning you just use equilibrium to analyze the structure, this will be equal. But let's say if this load is so large and it will cause your beam to deform so much, this guy will have a problem, because when you have a large deflection here, this gives you freedom so that the member can move, right? But here, your member is locked tight in horizontal direction in both ways, in both supports. So it will create another force, because this will only happen when you have a very large deflection. If you do not have a freedom for your structure to move, it will create another force, because it wants to go, but it cannot, right? Because you just lock them at both supports. This is what we call catenary effect. It's a very advanced second order analysis. A second order means that we include the effect of displacement into our calculation as well. So this is a classic scenario, you know, general case when we consider something like the temperature. You know, temperature, when you are in the extreme scenario, can cause your structure to come under a lot of stress as well, because a temperature will cause your structure to expand under hot temperature and maybe shorten under cold temperature. So from time to time, when for example, when we try to build a very long span structure, like a truss in the factory, it's long, and then you have the sun. Sometimes, because when you build the truss, in reality, you would want to place it maybe to the column. And when you place it to the column like that, the real scenario is that this is not a hinge. This is not a roller. And when you consider the temperature coming out down on the structure like this, the truss, which is made of steel, when absorbs so much heat, it would want to expand. And when it wants to expand, but you lock it, it's going to have additional stress due to temperature. And it's pretty much like this. So it will have the significant difference when we have something beside just the vertical load. For example, this is large deformation, and this is temperature gradient. Okay. So thank you for asking. I don't know if this is going to give you pleasure or pain, the answer. But just maybe to show that, you know, your world is beginning to open up. When you go out in the real world, sometimes the knowledge of equilibrium is enough. Sometimes It isn't. For example, another one of the secondary order. In the building, okay? When you have the wind blow to the building like this, your building will move to the side. It will have lateral movement. Do you agree? General question. Please feel free to answer. Do you agree that when you design your building against the wind, you cannot assume that your building will remain a straight line. It must deform, right? One thing that you learn from mechanics of materials is that whenever you have the load, you must have the strain and therefore stress. So when you have a load like this, your building will move to the side. It will have lateral deformation. So what if we look at the column that we design? At first, you design the column just like in your mechanics of materials. You know, okay, this is your free body diagram. So you design the column against this load. This is perfectly okay, right? But when you consider something like this, hey, we have the wind blow, so your building will not stay. It will go to the side like this. So the free body diagram of the column will be like this instead. And now, when you look at the same free body diagram from the left here, what you have is here instead. So is this under equilibrium? Yes or no?
Oh.
Think about it. Just don't over, stressing yourself. It just use your imagination, use your feeling first. You see, the two loads now do not coincide. These two loads, they pass the same point. So it's equilibrium, right? But when you have this, one load goes here, another load goes here. Is that equilibrium? No, it's not. No, it's not. That means you need to have the moment to balance this. So there will be additional moment added to your column. This is a secondary order analysis, which is there. It's going to be there. You cannot avoid it, because whenever you design the bigger structure, you will have more concerns like this. Buildings under window, it will sway. We call it sway. And once it sways, this will become the free body diagram of your column. And this is secondary order analysis. This effect is called P. This displacement is delta, so it's P delta effect. You must always consider this in high-rise building. So, wow, is that too much for you now? But you asked for it. I always want you to know more. Whether or not you get it now doesn't matter, but you are exposed to something new. It's there, it's real. No denying that. Okay? And that's the point why it's just a simple story about, this and this. They are not actually the same. Even though they're the same when you consider the typical load. Okay? All right, guys, that's time's up for today. At least you get your money's worth, right? Okay. Let me stop the record. We have 4 sessions to record now.